So now that we have taken a look at a demand curve and what's behind the demand curve, namely utility, units of satisfaction, now we're going to switch gears and we're going to take a look at that supply curve. And we're going to dive in deep with that supply curve and take a look at everything that's behind it. To begin, we are going to look at what's called the production function. We're not going to go to costs quite yet. So what our goals in this particular unit, you can see here on the screen: compute marginal product and average product, explain the law of diminishing returns, and explain the relationship between marginal product and average product. And of course, I still haven't learned how to spell the word "the" yet. I'm working on it. Anyway, so we keep using this letter P. So what is this P that keeps appearing? Now, obviously, it stands for product, but what does that mean? Well, in this particular unit, it's going to be very important to keep track of outputs and inputs. Remember, inputs are your factors of production, the items we use to produce outputs, which will then be traded on the open market. So the P, production, is the output level of the firm. Thus, you can read through this: average product, marginal product, and you also see TP appear. That's total product or total output level. Really what we want to do is we want to assess changes in outputs, production levels, given various input levels. So marginal product, being marginal, are changes that take place when a 1 unit change in input takes place. So how much output do we receive when we add 1 more input level? That's marginal product. Average product takes a look at a given input level and it averages out the outputs at that particular point. So we're going to assess these two items: marginal product, average product. And we're going to want to see, as we see number 3 in our goal up top, we need to identify relationships. So let's get into it. All right, so we're back to this world of math. Gotta love math. Let's make sure that we understand the schedule that we're looking at first. This first column here you see is input levels. These are amounts of labor. Now these, you can picture these as hourly if you wish. You can picture them as number of workers as measured in thousands. I'm just going to work with this particular data as you see it. Why don't we assume number of hours, labor hours being utilized. Total product, this is our output level. So 1 hour of labor can produce 1 unit of output. 1.6 can produce 2 units of output. 2 labor can produce 3 units of output, and so on and so on and so on. All right, down here are your equations. So average product, the equation is total product divided by the quantity of input. Marginal product is a change in total product divided by a change in quantity of input. So if we do the math and we do it properly, what we're going to do is when we calculate average product, total product divided by quantity of input. Quantity of input's 1, output or total product is 1. 1 divided by 1 is, hey, look at there, 1. So we go to the next one. 1.6 units of input, 2 units of output, so 2 over 1.6 is 1.25. 3 divided by 2 is 1.5, and so on and so on and so on. So go ahead and pause the screen, pause the video, and calculate the remaining average products just to make sure you got it. Okay, so if you calculated it correctly, these are the numbers you should come up with. Again, pause the video, check your answers. Now what we want to do is we want to calculate marginal product. Now marginal product is a change in total product divided by a change in quantity. So if you take a look here, the change in total product are by units of 1. I did this for a reason. In a later unit, we're going to look at relationships between costs and productivity, and we're going to want to line up this information. We want to have an axis where everything lines up. So I'm using numbers on purpose that will later make much more sense. Anyway, let's look at the math, because the math will be the math no matter how you perceive it. So marginal product is a change in total product divided by a change in quantity of input. So if we go from 0 total product to 1, that's a change of 1. Labor, we go from 0 labor to 1. That's a change of 1. 1 over 1 is 1. Notice this 1 is in between these two. That's because we're looking at a change, moving from 0 labor to 1 labor, then from 1 labor to 1.6, 1.6 to 2, 2 to 3, 2.35. And as we're looking at these changes, we're assessing what's changing with output levels. So these are all a matter of changes, what's taking place in that sense. So from 0 to 1 labor, the change is 1, marginal product is 1, and I line it up kind of in between to show this change. So the next unit is, as I go from 1 labor to 1.6, that's a change of 0.6. Total product is a change of 1. Therefore, if we do the math correctly, again, look at the bottom for the equation, we get 1.67. Here we change from 1.6 to 2, that's a change of 0.4, and we go from 2 to 3, that's a change of 1. If you do the math correctly, you wind up with 2.5. We go from 2 labor to 2.35 labor, that's 0.35 of a change. Output is yet again a 1 unit output. Boom, we have 2.86. Go ahead and pause the screen and calculate the remaining column. If you did your calculations correct, this is what we're looking at. So marginal is looking at a change in. How are we changing our inputs, and what's the effect of the input change on output levels? Now, under normal circumstances, we'll do 1 unit labor changes. Again, I'm using slightly different numbers here because of the connection we're going to make a little bit later on regarding relationships. Nonetheless, let the math be the math. Look at the equation down below, a change in total product divided by a change in quantity of input of labor. So total product column, input column, or labor, do the math. All right, so the next thing we want to do is we want to take this information and we want to graph it. Everything in here is graphed. So there's a little trick to this. Notice on the graph, the bottom axis is the quantity of input. So this labor column in our schedule goes down here on the bottom axis of our graph. I decided to number it by halves, 0.5, 1, 1.5, 2.0, and so on. This column here, AP and MP, I just take a look at the numbers in the AP column. In the MP column, I found the highest number, and then I labeled accordingly. 3.33 will be just above this when I plot that particular point. All right, so if you start with the average product, one labor, boom, 1.0, one average, 1. So 1 on this axis, 1 on this axis, a dot would go right there. 1.6 and 1.25. So 1.6 of input, 1.25, a dot would go right there. And then you do 2 and 1.5, 2, you slide it to 1.5, put a dot right there, and so on. Connect the dots, label it AP. Marginal product, however, you want to plot at the midpoints of the quantity axis. So the quantity axis is the labor. So between 0 and 1, which is 0.5, you plot the point 1. So at 0.5, 1. Between 1 and 1.6, so between 1 and 1.6 is about here, about halfway in between, you plot the number 1.67, which would go up here. So make sure that marginal product you are plotting at the quantity midpoints. Go ahead and pause the video, sketch out the graph, plot the points. If you did this correctly, this is what you should have come up with. Remember, the marginal product is the midpoint. So here's your first laborer here. Midway is 0.5. Here's your next laborer. So midway between the first laborer and the second laborer should be your next marginal product point. Here's your next laborer and next laborer. At the midpoint of those two workers should be your next marginal product point. Midway between these two workers should be the next marginal product, and so on. So remember, the marginal product is at the midpoints. All right, So what I want you to notice once we plotted this, if it's done correctly, a couple things. Marginal product first rises, it reaches an apex, then it decreases. Notice that. Everybody go, ooh, ah, awesome. All right, average product is really going to do the same thing, not quite as severe, more of a gentle slope. It's going to rise, it's going to reach an apex, then it's going to begin to decrease. Take note of the intersecting point. All right, listen carefully. The marginal product curve will intersect the average product curve at the average product's apex. This peak of average product is where marginal product will always intersect it. That is a very important concept. And the whole idea is, as long as the per unit value is greater than the average, it's going to pull the average up. As soon as the marginal per unit increase is less than the average, it's going to pull the average down. Think about your grades. If your grade point average, say, is a 3.0, any individual class, which would be a marginal, that you get a grade lower than 3.0 is going to pull your average down. That's what we see here to the right. If this class has a GPA, if you get a grade in that class lower than your average GPA, it's going to pull your average down. However, if you score a grade in a class higher than your average, again, assume your average is a 3.0, if you get an A in my class, it's going to pull your average up. So as long as the marginal is greater than the average, it's going to pull the average up. As soon as the marginal is less than the average, it's going to pull the average down. If we were to graph this, as you see, the apex of the average product is where the marginal product intersects it. So, generically, it looks like this. So here's your basic generic graph of average product, marginal product. Same basic shape as this one, but much more neat. All right, a couple terms we got to be aware of. First of all, the area of increasing returns is the area in which the marginal product is rising. That is increasing returns. The point of diminishing returns is the apex of marginal product. So when we reach that output level, that is the point of diminishing returns. Beyond the point of diminishing returns, when marginal product is decreasing, that's what we call the area of decreasing returns. So those are three vocabulary words you need to understand. As we're adding more of a variable input into a fixed input, if output levels are going up, as a result, that's increasing returns. If we add more variable inputs into a fixed input and we see that outputs are declining, that's decreasing returns. The tipping point is the point of diminishing returns, which brings about our law, the law of diminishing returns. As more of a variable input is added to a fixed input, overcrowding will occur and output levels will begin to decline. A fixed input, think of a McDonald's kitchen, not very big, it's fixed, there's only so much space. When I hire my first few workers, I'm going to be able to produce more cheeseburgers in that kitchen as I hire more and more workers. The first worker that has to do all the cooking and sell it to the customer is not going to be really productive. If I hire a second worker, they can specialize, have a division of labor, and between the two of them, they can increase productivity level. We're increasing returns. Hire a third worker, it gets better. Fourth worker, it gets better. But at what point do we overcrowd the kitchen to the point in which they're actually getting in each other's way? Well, when that begins to occur, we begin to see productivity levels decline. Now, how many do you hire? Well, we will discuss that later in the factor market. However, one observation you should make now, I can go ahead and hire in the area of decreasing returns as long as it's pulling my average up. So we don't necessarily want to stop at the point of diminishing returns. We can go beyond that. As long as it's pulling my average up, it's okay. So there's one realization that will become more clear as we go. And that ends the productivity how to do. We will do more practice in class. See you tomorrow.